Now let's look at the next problem, number 11. The function f of x equals square root of 3 minus x. And another function is g of x equals x minus 2 over 2x plus 3. So we want to know the domain for each function. So for the first function, so because 3 minus x is under the square root, so that means 3 minus x should be greater than or equal to 0, right? So 3 minus x should be greater than or equal to, let's solve for x for this inequality. So we subtract 3 on both sides, so it's negative x greater than or equal to negative 3. Then we divide it by negative 1. So we divide it by negative 1. Because negative 1 is a negative number. So if we multiply or divide by a negative number, you should change the direction of this inequality. So greater than or equal to becomes less than or equal to. So we have x is less than or equal to 3. Okay, so the interval notation for this one is negative infinity to 3 and a bracket. For this problem G, so because 2x plus 3 is in the denominator, so it requires that 2x plus 3 cannot be 0. Okay, so let's look at where the function 2x3 plus 3 equals 0. So 2x plus 3 equals 0. So we solve for x is 2x equals negative 3. So x equals negative 3 over 2. So when x equals negative 3 over 2, this 2x minus plus 3 would be 0. But we don't want to be 0. So in other words, so x cannot be negative 3 over 2. If you use the interval notation, so it would be negative infinity to negative 3 over 2, right? Another one is negative 3 over 2 to positive infinity. You see, it includes everything except negative 3 over 2. So, and then we connect these two intervals together. We use the union. Okay, so this is the interval notation. Now let's look at the next one, 12. So our f of x equals 5x squared plus 2x. We want to find f of t plus 1. Okay, so in other words, this position of x becomes t plus 1. Right? So f of t plus 1 is equal to 5 times x squared. X becomes t plus 1, so the whole thing t plus 1 squared, not just t plus 1 squared. Okay, don't forget the parentheses when you plug into the x. So you replace x with t plus 1, so it's 2t plus 1. Is that right? No. We have the parentheses. Okay, so now let's simplify it. So it's 5 times then t plus 1 squared. You can multiply out, it will give you this answer, t squared plus 2t plus 1 plus 2t plus 2, right? We expand it, 5t squared plus 10t plus 5 plus 2t plus 2. So it's equal to 5t squared plus 12t plus 7. So this is your answer. The next one is some definitions for the profit analysis. Profit loss analysis. So in the profit and loss analysis, the point where the revenue is R equals the total cost C. So we give a name. This point is called break-even point. So it's called break-even. Okay. Number 14. So it tells you that to sell X tickets, the revenue is given by R equals 15 times X. So this is the revenue. And the total cost is C. is equal to 1.25x plus 495. So how many tickets need to be sold each night to break even? So in other words, when will the revenue equals the cost? So the revenue equals the cost. So it's 15x equals 1.25, x plus 495. So we subtract 1.25x, we will have 113.75 x 495. So let's do the calculation. Okay. So 495 divided by 13.75, which is equal to 36. Okay. So in order to get break even, you should sell 36 tickets. And the next one is just a very simple question. 4x plus 3y equals 6. We want to solve for y, solve this equation for y. So in other words, we want to write it as a y equals something. So solve for y, so we subtract 4x on both sides, so it's 3y equals 6 minus 4x. Then we divide it by 3, so this would be 2, negative 4 over 3x. So in general, we would like to write the x term first, so it's negative 4 over 3x, then plus 2. Okay, so this is your answer. So the next one is the donut shop has a fixed cost $124 per day and a variable cost of $0.12 per donut. How many donuts can be produced for a total daily cost of $250? Okay, so for this one, we let x be the donuts should be produced, okay? Number of donuts should be produced. So the total cost is consists of two things: a fixed cost, which is $124, plus a variable cost. The variable cost depending on the product, the number of the product produced, right? So here x, now the number of donuts, so which is 0.12 times x. This is the total cost. So the problem asks you to get the total cost, which is 250. So how many donuts we should produce? So we subtract 124. So it would be 126. And divided by 0.12. So this is equal to 1050. So we needed to produce 1050 donuts. Okay, so now let's look at the next one. Number 17. A company manufactures the memory chips for computers. So the price demand function, they know that the price demand function, using some techniques to get price demand function, is P of x. P represents the price. 75 minus 3x, where x is greater than or equal to 1, less than or equal to 2. So x means x million chips. So here's x, it means x million chips. Okay. The problem is, what is the revenue if the company sold 4 million chips? Okay, so in other words, when x equals 4, what is the revenue R? So we know the revenue should be the price times the total number of the chips produced, right? Chips produced. So we need to find the price. Price, we use the price demand function. So here is when x is 4. So P of 4, the price when x equals 4 equal to 4 million, okay? So here's x equals 4. So 4 minus 3 times 4. So you cannot write down the 4000 because here x represents million chips, okay? So it's 4. So this would be 12, 70 minus 12 would be 63. So this is the $63 per chip. So what is the revenue? Revenue is equal to 63 times how many? 4 million. So 4 million is this one, right? So this would be equal to 2, 25 here. 1, 2, 3, 4, 5, 6. So this is the total dollars. Okay, this is the revenue. So now let's look at number 18. Graph the function f of x equals x plus 1 when x is less than 1 equals 3 when x is greater than equal to 1. Okay, so when x equals 1, less than 1, f of x equals x plus 1. So let's just take it. This is a linear function, we just need 2 points. So for example, x equals 0, so it's 0 plus 1, right, equals, we take this branch, 0 less than 1, so we take x plus 1 for f, it's equal to 1. X equals negative 1, so it's negative 1 plus 1, which is equal to 0. So we have 2 points. So this is 1. And here we have 0, 1 point, 0, 1 point, 0, 1. We have negative 0, negative 1, 0. So we connect these 2 points. Of course, you should continue, right? However, if x, for this part is greater than 1, greater than equal to 1, so we need to erase this part, right? We stopped at x equals 1, but x equals 1 is not included for this branch, because this branch is for x less than 1. So this here is a circle. When x greater than equal to 1, equal to 3, so it's 1, 2, 3. 3 is here. So when x equals 1, it's equals 3. When x equals 2, it's also equals. When x equals 3, it's 3. So it's a horizontal line, right? Of course, when x equals 3, we have another part. However, because x less than 1 is given by this branch, so we have no this part. So this would be your graph. We need to erase the other side. Okay. 18, 19. So we use the graph to find f of 20. So from the graph, which would be equal to, when x equals 20, f equals negative 10. Okay. So this is the function 5, 8, 11, 14, 30, 48, 66, 84. Right. For this one, the domain, this is the function, right? One element on the left side, this is a function. The element for each element on the left side corresponds to only one element on the right side. So this is the function. What is the domain? Domain is the collection of on the left side. So the domain is 5, 8, 11, and 14. What is the range? Range is the collection of all the correspondence. So 30, 48, 66, 84. So this is the range. 21. Determine whether the graph is the graph of a function. Explain why. So this is a circle. So for this one, we can use a vertical line test, because the vertical line test intersects the graph at 2 points. So this is not a function. Right, the reason is this vertical line intersects this curve at more than one intersection points. Okay.